All right, 15, we have several parts. We're going to be reading the graph and getting our answers from the graph. So A and B, we're going to look at exact function values. So this function notation says, here's the x value, what is the y value associated with that x value. So if we go to -2, if I look up and down and trace this graph, it hits this blue line right here. That line corresponds to a y value of -4. So from reading the graph, x is -2, y is -4. As an ordered pair, -2, -4. Okay. Same thing for f of 3. We're going to go to +3 right here. X is 3 all along this vertical line. It hits the graph right here. This value corresponds to a y value of 2. So 3 corresponds to 2. The ordered pair is 3, 2. All right, so the next part, we want to find all of the x value for which f of x is equal to -1. F of x is y, the y value. Where is y equal -1? All right, so here's the y-axis. We're going to go to -1, and we're going to go left and right. It hits this point 1, 2, 3 times. So we get a -3, a -1 for the x value, and a +1. -3, -1, +1. Okay, so those values or ordered pairs are -3, -1. X goes first. -1, -1. And then +1, -1. And then it says, thus, f of x or y equals -1 when x is -3, -1, and +1. Just reiterating what we just labeled. Part 3, we want to find all of the x values for which the y value is equal to -4. So again, we're finding x values, but this time y is -4. Okay, so if I go up here, the y value is -4. It hits 2 times, this dot and this point. So this happens at -2 and +2. That's when we get a -4 in the y direction. All right, so we have -2 and 4, -4, sorry, and then +2 and -4. And again, those two x values are -2 and +2. E, we're going to enter the x-intercepts in ascending order. Approximate to 1 decimal place. Says an x-intercept is a point where the graph crosses the x-axis. So we're going to look and see where this graph crosses the x-axis. Okay. So this point right here at 0, and then over here, this looks like maybe -3 point, not quite a half. We can say 3.2 or 3.3. So let's say -3.2 and 0, kind of going in ascending order, smallest to largest. Y-intercept, where it crosses the y-axis, right here, only one place at 0 as well. So the order pair is 0 for x and 0 for y. G, we want to determine the domain of f, and then we're going to write it in interval notation and determine the range. Okay, so let's look at this graph. So how far to the left does it go? Okay, even though it's going upward, it's also going to the left. So as far as a left end is determined, the domain is going to go all the way to -infinity. Okay. Then I start tracing this to the right. So I'm going to the right. This is a connected line, so I get all of these points from negative infinity up to 2. Now there's a break at negative 2. So I do have a value at negative 2, and then it jumps up here, same value, negative 2, but then it picks right up and goes to the right forever. So if I'm tracing the x-axis and I'm looking up and down, it's going to hit a blue line no matter where I'm at on this graph. So even when I get to 2, it might not hit that part, but it hits this part. And then it keeps hitting blue lines up and down because x goes across, but the values are looking up and down. So this goes from 2 to positive infinity as well. So it goes basically from negative infinity all the way to positive infinity. And every value gets hit. Okay, so that's our domain. Our range. Let's look at our range. The lowest point on the graph is negative 4. Nothing below negative 4, smallest point. So we actually do reach negative 4, so we'll put negative 4 in a bracket. And then I go up. How high does the graph go? Now I know there's a break, but we do get this point. We're just looking at the y value. So this is at 2, and we do get a value of 2, even though we got a separate piece. But we're looking up and down. If I was to draw horizontal lines, would it hit the blue line? And since it goes up forever, that means it's going to go all the way up to positive infinity. So our range is negative 4 to positive infinity. Domain negative infinity to positive. Range negative 4 to positive infinity.